All right, let's talk about something you've probably never given a second thought to, the humble hose. We're surrounded by these things, and we think we know what they are. But today, we're going to peel back the layers on this everyday object, and I promise you there is a surprising world of science and engineering hiding in plain sight. You know this one, right? The good old garden hose. You water the lawn, you wash your car. It's just a tube, basically. It moves water from point A to point B. Seems about as simple as it gets. But if a hose is really that simple, then what in the world are all of these for? See, we've just stepped out of the backyard and into the world of industrial hoses. And out here, it's a whole different universe of specialization. I mean, look at this thing. That coil isn't just for looks. This hose is built to handle the constant, high pressure of compressed air for power tools. Or what about this one? You can literally see the steel wire spiraling through it. That's there to stop it from being crushed or collapsing on itself. And then you've got this red hose, which does the exact opposite. It's designed to go completely flat so you can roll it up. So how do you get so many different designs from one basic idea? Well, it all comes down to their anatomy. You see, the secret to any industrial hose is that it's not just one thing. It's almost always made of 3 different layers, all working together. You can think of it as a 3-layer story. So here are our 3 characters. First, you've got the tube. That's the inner lining. Then there's the reinforcement, which is like the muscle of the operation. And finally, you have the cover, which is the protective outer skin. Let's dig into each one. Okay, layer 1, the tube. This is the part that's actually touching whatever is flowing through it. And that's its whole job. So it has to be perfectly compatible with that substance, whether it's plain water, corrosive acid, gasoline, or even food. Now check this out. This spec is from a welding hose. The inner tube is made of a special compound built to handle oxygen and acetylene. These are incredibly flammable gases. You can't just use any old rubber for that. The wrong material could degrade, leak, and cause a disaster. This is where the engineering gets really serious. All right, next up is the middle layer, the reinforcement. This is the muscle. This is what gives the hose its strength. It has to fight the pressure from the inside that's trying to make it explode, while also fighting forces on the outside that might try to crush or kink it. And this is where the variety really comes in. The reinforcement could be a woven mesh of super strong synthetic fibers, which keeps it flexible. Or it could be a heavy-duty spiral of steel wire, which makes the hose rigid and keeps it from collapsing when it's used for suction. And that brings us to our final layer, the cover. Think of this as the hose's armor. Its job is to protect those 2 important inner layers from everything. From being dragged across rough concrete, from sunlight, from extreme weather, and sometimes even from fire. Let's go back to that welding hose again. Look at the specs for its cover. It's not just tough, it is explicitly flame resistant. And it has to be, right? It's going to be used around flying sparks and intense heat. So you see, each layer is a specific solution to a very specific problem. So, now that we know the 3-layer principle, let's put it into practice. We're going to compare 2 very different hoses that on the surface might seem kind of similar, but their inner construction tells you everything you need to know about what they're built to do. So on the left, you've got your PVC lay-flat hose. See how it's soft, it's collapsible, and on the right, you have the PVC steel wire hose. It's rigid, it's see-through, and you can spot that steel reinforcement right away. This table really lays it all out. The lay-flat hose uses that flexible fabric reinforcement. That makes it perfect for discharge, just pushing lots of water out, and then it collapses down for easy storage. Think farming or irrigation. But the steel wire hose, that rigid steel reinforcement means it's built for suction. It can't collapse even under a vacuum, so it can pull liquids in. That's why you'll see it in places like shipyards or connected to heavy machinery. Same material, PVC, but totally different engineering for totally different jobs. Okay, let's talk numbers for a second. Because when you're dealing with industrial hoses, you're dealing with some serious forces. The pressure ratings you see in a catalog, they aren't just suggestions. They are the absolute language of safety and performance. And there are 2 big ones you gotta know. First is working pressure, or WP. That's the maximum pressure the hose is designed for in normal use. Easy enough. But then there's burst pressure, or BP, and that is exactly what it sounds like. It's the pressure where the hose will fail, catastrophically. It's a safety margin, and you never, ever want to even get close to it. And how much can these pressures vary? Well, take a look at this. A light-duty lay-flat hose might be rated for about 4 bar. To give you some context, 1 bar is about the same as atmospheric pressure at sea level. Now compare that to a heavy-duty spray hose rated for 40 bar. That is 10 times the pressure. And that entire difference in strength comes from the engineering of that middle reinforcement layer. So what does a number like 30 bar even mean? For some heavy-duty hoses, that's just the burst pressure rating. It's a mind-boggling amount of force to contain inside a flexible tube, and it's a testament to just how strong those hidden reinforcement materials really are. It's a safety number that screams, "Do not mess with me." So when you put it all together, the layers, the materials, the pressures, you start to zoom out and see something much bigger. We've been looking at specs in a catalog, but what we're really looking at is a vital, hidden network that keeps our world running. These things, they really aren't just hoses. They are the veins and arteries of our entire industrial world. They are the circulatory system carrying the lifeblood of our economy. They move the water that grows our food, the fuel that powers our vehicles, and even the liquids that end up in the food and drinks we consume. They are absolutely everywhere, doing critical work, almost completely unnoticed. And that really brings us to the big question, doesn't it? We just took apart a simple hose and found an entire world of specialized science and engineering packed inside. It kind of makes you wonder, what other simple things are all around us, just hiding their incredible complexity, waiting for us to look a little closer?